Hi, this is Tor Lacey with a lecture about topographic maps. Learning objectives include use contour lines to interpret slopes and the shapes of landforms, use contour lines to determine elevations and relief, use contour lines to identify erosional and depositional landforms, and interpret and create topographic profiles. Let's start with some map themes that you might be familiar with. Political maps show the geographic boundaries of countries and large or important cities. Climate maps, like this one about average annual temperature, present the distribution of different types of climates or climate factors. Street maps are used for navigating by automobile and are probably the map theme we are most familiar with. Topographic maps use contour lines to depict the shape and steepness of Earth's surface. Contour lines are the definitive characteristic of topographic maps. These lines are shown in brown on land and blue on water, and are drawn to connect points of equal elevation. With a little practice, a viewer can interpret the elevation, slope, and shape of the landscape. Every fifth contour line is an index contour, which is used to index or indicate the elevation along that contour line and is indicated with a thicker, more heavily weighted line. The contour interval is the amount in feet of elevation gain or loss from one contour line to another. On this map, the contour lines show hills in the northern half of the map and city streets where the topography is flatter. What's the contour interval for this map? Considering that each index contour represents an elevation change of 100 feet, and there are 5 contour lines per index contour, 100 divided by 5 equals 20 feet. Let's check if that works. Starting at 500, 520, 540, 560, 580, 600. Contour lines that contain hatchers represent a closed depression like the crater at the top of a volcano. Let's check our ability to interpret contour lines. On the left are landforms depicted by contour lines from a map view perspective. Think of yourself as an airborne bird looking down on Earth's surface. On the right are what these landforms look like from the side, also known as a cross-section or profile view. Please pause the video and quiz yourself by matching the numbered landforms on the left with their lettered equivalent on the right. Map scale indicates how distances on the map relate to distances in real life. A map with a fractional scale of 1 to 250,000, for example, means 1 unit of measure on the map, say an inch, is equal to 250,000 of that same unit in real life. Smaller scale maps, like 1 to 250,000, show more area, but less detail, in comparison to larger scale maps that show more detail but less area. Topographic maps always have a graphic or bar scale, which are used to quickly estimate the distances between two different places on the map. Contour lines allow for the steepness of slopes to be calculated. Knowing the steepness, also called the gradient, can be helpful when assessing geologic risks and planning developments such as homes or roads. You might recall solving rise over run problems in a math class. The same logic is used here to calculate gradient, as summarized in these steps. I hope you've enjoyed this presentation about topographic maps. Thank you for listening.